So with this function written, let's now check if the anim q or the anim quaternion it's pointing in a different direction than my q. So after the quaternions are created, let's store the output of this function in one variable. I'll call that variable quatCompare, and let's invoke the function, and you need to give it the two quaternions. So let's give it my q and anim q. So as I explained you before, this is gonna give you one float that goes from values that are below or bigger than 0. If they are less than 0, then it means that anim q is pointing in a different direction. So we need to flip it. In order to achieve that, let's use an if condition. So if quatCompare it's less than 0, I want to flip anim q, and that's it. I usually like to make things very explicit, although I don't really need it. So I'm gonna also do an else and say that anim q it's gonna be multiplied times 1. You might have realized that I made a mistake here, so it's not times anim q, of course. I don't want to multiply it times itself, I want to flip it. So this should be -1. Now you can see that the rotation it's actually been followed, but it's we can increase this value so it's a tad higher, so it follows the orientation a bit closer. So let's set this to 3. And you can see you get a similar result to what we had before with the matrices that we created in this wrangle here. So all this sorts the problem that we had at the beginning. So we wanted to follow the target position, and we also wanted to follow the target rotation. So this is it. So the next thing we need to do is apply or try this in a more complex scenario to see if it actually works. Before doing that, let's create a null and let's call this out, just to keep things clean. I didn't want to make this video longer, so I prepared this very little scene here where I created one biped and set the animation to run. Then if you dive inside character following, I'm gonna show you what it's going on inside, so I don't have to create it again from scratch. So I'm merging the biped, I'm scaling everything 10 times, so this guy is currently is huge. I'm converting and polyfilling the holes in the geometry so I can create an ISO offset. I'm freezing the animation on the first frame, ISO offsetting the geometry, scattering points inside the volume. Currently I'm scattering 500 points. And then I'm randomizing the normals. Copying some boxes so they intersect and everything, I don't mind that. Then I'm configuring the RBDs. I'm setting the name to box, setting the active to 1. I'm also adding one attribute called found overlap, which helps bullets separating geometry if they are intersecting on the first frame. And then I'm point deforming everything using the original animation of the character, so you end up with this. Something very important to keep in mind is that the transform, it's been affected. So if you remember from the previous tests, you know that this transform it's created after the geometry is packed. And because we are deforming the geometry after the packing has happened, you get the intrinsic transform also being modified. So this intrinsic transform contains the information of rotation, and that's exactly what we need for the targeting system. So let's go back to our original setup. Let's copy these few nodes, the time shift and the two nulls and the dot network. I'm gonna Ctrl C, Ctrl V. Let's reset the simulation, and my hope is that it's just going to work. And the reason is because in here we made the proper job of setting the find attribute value to compare with the name. So let's press play, and you can see it's working. Let's display flag the target, and you can see that there's a delay. They are trying to follow the target, but they are dynamic and they are colliding. And you can see at the beginning how boxes that are intersecting, then on the next frame they are not. You see? The intersection disappears. So now we know this works in a more complex scenario like this one. So you can imagine this being used in motion graphic setups or even magic setups. I have used this in a lot of projects, so I'm pretty sure you can find uses for this. I also made another example, which is the one that you saw at the beginning. And it's exactly the same thing. The only difference is that I'm deforming the boxes as we did before. Then I'm doing one simulation that has nothing special. It doesn't have the subsolver with the targeting forces. It's just a dop network that allows the boxes to fall. I wanted to have an initial rotation, and it has a lot of noise, so they get spreaded. And if I go to the last frame, this is what you have. It actually seems like I have to time shift this to the first frame. And this is the last frame of this simulation, so you can see that they are already on the ground. And what I wanted to have here is a starting point for this dub simulation. So they start on the ground, and then they try to reach the target, which is the guy who's running. And that's exactly what's happening. So this is the same system we did before, but it's used in a slightly different scenario. I'm gonna show you what the differences are. For the position follow, I'm just animating these forces. That's exactly how I'm making them follow the target. And then at the end of the animation, they are just falling because I'm setting this to 0 at the very end. So you see, they just fall to the ground. They fall very slowly because the character is huge, so that's something that it's good to keep in mind. And I'm doing the same with this. You could also animate the C and the K on both of them. I did that on the test that I showed you at the beginning of the tutorial, but unfortunately I lost that file. The other thing I'm doing here is setting a random value called random value, which is using the ptnum as the source of rand, and then I'm basically fitting that range of the random value between 0.2 and 1. And then I'm multiplying k times that random value. So this k is not exactly the same for all of the points, so they are not all the same. So that summarized the whole thing. I really hope you enjoyed these tutorials and you learn a few tricks, and I will see you in the next one. Bye.